If it helps, we'll do one here together. 3x squared minus 12 equals 0, right? To find critical points, you're looking where it's 0 or undefined. I'm going to write that over here just to remind us that it's where it's undefined. The problem is most of the things we look at are defined everywhere. Like this function is never undefined. It's always defined, so people tend to forget about that. But if you go through and solve this, you get x squared equals 4. It's almost like somebody made that up so that it would come out to be nice numbers, right? Actually, that one, I can't remember. It might be in the textbook. If you have two values, it's going to divide it into 3 intervals, right? At the risk of causing more problems. Like you're amazed every time. It's like your goldfish, eh? You forget what happened 30 seconds ago. Oh, look, a number line. Wow, that's exciting. -2, +2. Oh, look, a number line. That's exciting. 2 points divided into 3 intervals. So in my table, I am going to make 5 little spaces because I want to talk about where x is equal to -2 and where it's equal to +2 and where it's less than -2 and where it's between. I should put the lines before I completely cause a problem here. And right here, we need 5 spots, right? Because we got the 3 intervals and then the 2 points I might want to write something about. So that's how I'm going to do this here, right? So we got greater than -2 but less than 2. And then we have x is greater than 2. And we want to look at what's happening with the derivatives, or the derivative in that case. The first derivative here is, so we know that it's 0 at each of these 2 points, right? First derivative 0 there. You probably know something from grade 11 about what this function is going to look like, and at that point it's already enough to answer the questions here, or to decide where it's increasing and decreasing. But we'll pretend you're like a goldfish and you forgot that from grade 11. And you say, and if you happen to graph it later and thought, oh look, it's a curve like this that starts down low and has 2 bumps on it and goes up to the right, and it's not in the middle like that, but whatever. You can probably already tell that it's going to be increasing, then decreasing, then increasing. But if you didn't know that, you could test a point in here, right? I don't need to see your work or your, what you've done to test it. I'm assuming you can plug a number into that expression and see what it is, right? If you picked a big, huge negative number, well, big, huge being far to the left, like -10, that's a big number, or a small number. If you put that in here, what's this going to turn out to be? So here's you thinking, right? Actually, maybe it's more like, no, it's kind of like that. You're asleep, but you slightly wake up here. I don't know. Your head is oblong shaped there. You think it's sad? Okay, you're thinking, you're not necessarily writing this, you're thinking 3 times negative big number squared minus 12, right?
How come he doesn't have a nose?
Well, I don't know. Or ears, or a hair, or any of that.
Or a body.
I'm going to keep track of 2, so I'm 2 things I shouldn't have done.
What was the first thing?
The first thing was talking about the attendance.
Well, maybe the third thing you should have done is putting those 2 things, because now we're talking about what you should have done.
Yes, there we go. Third thing, you're right. 3 times negative big number squared minus 12 is positive. Right? Or more specifically, something like -10 or -100 or something in this range right here, right? All you want to figure out is that this is positive. So if you put a number like -10 in that interval, then you get, a number that's going to be positive. That's all we care about here, right? You want to see that derivative is positive. And then you try a number in this interval. So you now make it, you're still thinking here, what would be a good number to try there? 0 would be the easiest one, and you know that this is negative. And then it's not always going to, don't automatically just alternate them, because some functions could go like this, and then you get another negative like that or something, right? It might change, it might be negative and then negative again, but here you do a number like 10 and you realize that that's positive, so you put a positive in there. You don't have to kind of show what you're thinking using this. And actually, a note about this now, not that you'll necessarily remember if you're taking the AP exam, you need to, on the AP exam, writing this table isn't necessarily enough. You have to then explain why this is. Like if you were going to say that this is a, what is this? We got negative to positive. If you're trying to explain why this is a minimum, you have to explain it. And all you have to do is say it changes from negative to positive, and it's 0 there, therefore it's a minimum. But you can't just put the table and assume that everybody understands what you can't assume they know you know what's going on there. This is a minimum because it changes from negative to positive. This is a maximum. What do we have to say in here? What's happening in this first one? If this is positive, it's increasing. If this is negative, it's decreasing. And then it's increasing again. Okay, seems simple enough. If you want to confirm it graphically, you put it on the calculator, or just using your understanding of grade 11 for those functions. Whatever it is here, who knows where it is, but you could actually, you could use this to draw the graph even if you don't have the calculator, right? If you wanted to draw the graph, just use that. You could actually, calculate a few values if you really had to, but we have at -2 here, we have some kind of a maximum. I don't know if it's above or below the axis, but it's, you could put the number in and find out if you want. It probably is way above the thing. You could put in +2 and find out that we're looking negative here somewhere, I think. But you know that it has some kind of a max there. And the other thing is you can notice that the y-intercept is this constant term here, right? If you're really trying to graph it, it looks something like that. So probably this dot's in the wrong place, but shouldn't it be what?
2 squared is 4 times 3 is 12.
2 squared is 4 cubed.
Oh,
You're looking at the derivative. So, whatever, it does something like this. Again, we know that from grade 11 that it's going to go up, down, then back up again, but that's to confirm it. You can actually find these points on the calculator and see that it's at -2. Are we okay with this? This is not such a nice one. I've done the easy one and left you with the not such a nice. Well, it's not that it's not such a nice one, but it's not a polynomial. It's got that involved there. Finding the critical points. Finding the critical points here. You could actually, factor that the same way as you always did, x cubed minus 3. So you could write it as factor, and this. If you want to know where that's 0, first you have to find the derivative, but then you can work with what you have. But you can work with that just the same way as anything else and think about where it's 0. Can you try some of the questions involved here? And then we have a request later to do a quick review of things.